Hi everyone. Today we are going to start another important class of organic compounds, that is phenols. Okay, and this video will be the introductory part of the chapter. Okay, so the phenols are the organic compounds that are functionalized by the presence of a hydroxyl group, and this hydroxyl group is directly attached to a carbon that is the part of an aromatic system. Okay, so as we previously learned about the alcohols were also characterized by the presence of this hydroxyl group, and phenols are again they have the functional group as a hydroxyl group. Okay, and this hydroxyl group is attached to the carbon that is the part of an aromatic system, or we can say that the hydroxyl group is attached to an aromatic system directly. Okay, it's directly attached to an aromatic system, so such a class of compounds we call as phenols. Okay, phenol is the basic member of this family, and the whole family of this organic compounds have derived their name from the phenol. Okay, and phenol is what? It's monohydroxybenzene. This is the phenol, monohydrox. It has one hydrox, monohydrox, and that's attached to the benzene ring. This is the basic member of this family, and the whole family has derived its name from this particular compound. Okay, we call it as phenol, and this is the monohydroxybenzene. It's also known as benzenol, or it's also called as the carbolic acid. Okay, these are different names that are given to the phenol. Okay, so phenol is not this single compound. When we talk about phenols, and it is the whole class of organic compounds in which this hydroxyl groups attached to an aromatic system. And in phenol itself, which is the basic member of the family, in this compound, the hydroxyl groups attached to a benzene ring. Okay, we have different examples here. This is called as cresol. Okay, this is cresol. This is dihydroxybenzene, and their actual name will cover in the nomenclature part. Okay, this is dihydroxybenzene. So these are different examples of the phenols. Okay, if we look at the phenols, and phenols are widely used in the household products. We use many disinfectants to clean the surfaces, to clean the mirrors, to clean the bathroom surfaces, to clean the different surfaces in the house. Then these all of these are the phenolic compounds. Okay, they widely use this phenol and phenolic derivatives as a basic product, as a basic component. Okay, so phenols are widely used in household products. For example, phenol itself in low concentrations, we use it as the disinfectant in household cleaners and in the mouthwash. In industry also, phenol is used as a starting material to make many plastics, explosives such as picric acid, and drugs such as aspirin. Okay, with the formation of aspirin, which used for the heart diseases, that's also started with the phenol. Okay, it's mixtures of different phenols. They are used as wood preservatives. Phenol derivatives have been used in the preparation of many cosmetic products. Okay, sunscreens, hair colorings, and many other cosmetic products. Okay, although its use is a little bit toxic, and it's banned in its use is banned in many countries. Okay, and it was first used as an antiseptic, and was used by the Joseph Lister for the surgery first time in 1867. Okay, as an antiseptic. So this is just some common uses and overview of the phenols. Okay, and if we look at the different types of, if we try to classify the phenols, then we have basically these three types of phenols. We can have phenol which is monohydric phenols, in which we have one hydroxyl groups. We can have different types of products in this class. We can have dihydric, we can have trihydric. This is the simple classification. We don't need to go into detail of these. Okay, and if we give some examples, for example, we have here, this is the monohydric phenols. We look at how we try to how we name these compounds. We look at some examples. Okay, so this is a typical phenol. basic example, this is a phenol. This is O. What O means, actually this position of the phenol is called as the ortho position. This is ortho position, okay. And this M means the meta position. This is meta position. And P means the para position, para, okay. So the hydroxyl group, with respect to this hydroxyl group, we name different carbons according to their position. So the carbon which is next to the hydroxyl group, as we have in this case, these are two O carbons, that is two ortho positions, two ortho carbons we have in this phenol. We have two meta positions, okay, and we have one para position. So these are different, these are the positions of different carbons, and they are named according to this nomenclature: ortho, meta, para, okay. And look, this is an example in which we have a phenol and we have a methyl group attached to a phenol. This compound, as we already said, that this is called as cresol. The general name of this compound is cresol. This is cresol, okay. And since is the ortho position, this in this compound the methyl group is at the meta position, and in this the phenyl group is methyl group is at the para position. So we call this as ortho cresol, we call this as meta cresol, and we call it as the para cresol, okay. This is the nomenclature, how we give the name according to the position of the methyl group in this particular example, okay. This is the general name of the compound, okay. If we try to name it according to the IUPAC nomenclature, then we have to specify the positions. And if we try to the name, this is the first, this is the carbon 1, will give this number. We'll try to number, if we give the numbering to the carbon, then this carbon is at the number 1 position, and this is 2, okay. So we call this as 2-methyl phenol, okay. And this will be numbered as 1, 2, 3. So this is 3-methyl phenol, okay. And this is at 1, 2, 3 and 4 position. We call it as 4-methyl phenol, okay. This is the IUPAC nomenclature. We name it according to the numbering of the carbons, and the common name is given according to ortho, meta and para position of the phenyl of the methyl group, okay. Now talking about the dihydric alcohols, we have taken 3 types of dihydric alcohols here, in which we have 2 hydroxyl groups. In this case, the hydroxyl, one of the hydroxyl groups is at ortho position. In this case we have at meta position, and in this case we have the hydroxyl group at para position, okay. So if we name, the general name of these particular compounds is, we call this particular compound as catechol. This is called as catechol. This is the common name of this compound, okay. This is catechol. This is what you call as resorcinol, and this is hydroquinone, okay. This is the famous one. So this is in general naming. This is called as catechol, this is resorcinol, and this is the hydroquinone. And if we try to name it according to IUPAC nomenclature, then we will number it. This is the position 1, this is the position 2. So we will call it as 1, 2 dihydroxy benzene, okay. And in this we have 1, 2, 3. This we will name it as 1, 3 dihydroxybenzene. And in this we have 1, 2, 3, 4. So we name it as 1, 4 dihydroxybenzene, okay. So these numbers specify the position of hydroxyl groups. Although we are going to discuss the nomenclature of all organic compounds in this detail, so here we have to just keep these these common names and this simple nomenclature in mind. Okay, similarly we have trihydric phenols. If we name again the common names given to these compounds, these are three examples, typical examples that we have taken. So if we try to name this one, the common name of this phenol is pyragalol. This is called as pyragalol. Okay, and this example is called as this is known as hydroquinol. This is hydroquinol, and this is fluoroglucinol. Okay, these are the common names. We don't need to we just need to remember these things. This is not that much important. And if we look at the IUPAC nomenclature, again we have to number the carbon. So we'll start numbering from this carbon. So this is 1, this is 2, and this is 3. So the name of this particular phenol will be 1, 2, 3. 1, 2, 3 trihydroxyphenol. Okay, and this is 1, this is trihydroxybenzene. This is 1, 2. Again we have to number it 1, 2, 3, 4. So we have 1, 2, 4 trihydroxybenzene. And in this case we'll number 1, 2. We can number from this side or from this side. We can start numbering from any of the two sides. We have a choice: 1, 2, 3, 4, and 5. So this is 1, 3, 4, 1, 3, 5. Sorry, it's 5 trihydroxybenzene. Okay. So here just we have to remember the things. We'll discuss the system of nomenclature and rules of nomenclature of different organic compounds separately. Okay. Here we have another typical example. It's not important that that we have a single ringed aromatic compound. We can have multi-ringed also. As in this example, this is what we call as naphthol. This is naphthol. Okay, this has been derived from the naphthalene, and naphthalene is an aromatic compound with 2 benzene rings attached. Okay, 2 benzene rings. I have 2 benzene rings. So this is naphthalene, and from this we have derived this naphthol. Okay, so that's why it's called as naphthol. And in this case we start numbering from this carbon. This is carbon number 1 in this case. This is 2, 3, 4, 5, and so on. So this is 1 naphthol. If the hydroxyl group is present at this position, if the hydroxyl group is present at 2 position, then we will name it as 2 naphthol. And if it is present at 3, carbon number 3, then it will be 3 naphthol, and so on. Okay, so this is just an example that this is also a phenol, and phenols can be multi-ringed compounds also. Okay, then we have 2 benzene rings as in this case, and we can have different examples of this. So in any aromatic compound in which we see that there is a hydroxyl group present, it is a phenolic compound. Okay, it's a phenolic compound. So we have some typical physical properties of this particular class of compounds. First of all, these are colorless liquids. At room temperature, if we see, these liquids are color, they have no color, they just look like water. Okay, and they can be white solids at room temperature. Okay, colorless liquids and white salt. Some examples of phenol, if we take then we have they look like solids, white solids, but at room temperature. And if increase or decrease the temperature, then the physical property, the physical appearance of the phenols also changes. In phenols, there is strong hydrogen bonding, and this is actually intermolecular hydrogen bonding. Okay, there is strong intermolecular hydrogen bonding. The hydrogen bonding between one phenol and another phenol molecule is very strong. That's why these have high boiling points. Okay, these have high boiling points, and this is the reason also that they are comparatively enough soluble in water. Okay, they are soluble in water as compared to alcohols. And at higher concentrations, the phenols are toxic also. Okay, at lower concentrations they are not that much toxic, but at higher concentrations they are toxic. They can cause irritation to skin, they can poison the living body. Okay, so they cannot be consumed as it. So these are the different simple physical properties of the phenols. Okay, so in the upcoming videos we'll discuss other aspects of phenols. We'll discuss the chemical properties, we'll discuss the chemical reactions, and we'll discuss the methods of preparation and another key aspects of these particular organic compounds.